Hello, ladies and gentlemen. So today we are going to take a look at how we can apply these ideas of trigonometry and special right triangles on the coordinate plane or on a graph, and how this connects to upper level math classes is going to be a big connection we're going to try to make today. So today we are going to look at finding values of trig ratios, sine, cosine, and tangent, for larger angles, and drawing our own diagrams and what are called reference triangles. So for just a minute, I want you to go ahead and think about this in your calculator. You can type in the sine of 100. You can type that in, and it gives you a decimal value, right? It gives you 0.9848. And right now you should be thinking, well, wait a minute, Kincaid, I thought sine, cosine, and tangent were set up based on the acute angle. And you'd be right. So how is it that you can find the sine of an obtuse angle like 100 degrees? Why does that exist? How does that exist? Or what do these values mean if I type in a value that's, say, bigger or 90 or bigger? So let's take a look at what we're talking about here when we talk about sine, cosine, and tangent for larger angles and even negative angles. So in your notes, I want you to draw this little coordinate plane here. It doesn't have any numbers on it. It's just x-axis, y-axis like normal. There are two big things you need to think about. First of all, there is something called a reference triangle, and it is a triangle created when you draw a line from the terminal side of an angle perpendicular to the x-axis. And then there's also something called a reference angle, and that's the angle located at the origin on your reference triangle. Both of these deal with drawing angles that are bigger than that acute angle that we've been setting up. So, for example, how is it that the sine of 100 works? What does that even mean? How do we figure that out? Well, I want to think about this little diagram right here, and I'll show you what I mean in a second. We can draw the angles, like let's say 120, by drawing a simple starting side. It will always be over here on the positive side of the x-axis, and we would draw that angle like this. This would be 90, right? And a little bit more. This would be 120, roughly. Now, if this is 120 degrees, that is not the triangle that we're looking for, okay? There is something called a reference triangle that can be made by drawing the angle on the coordinate plane like we just did and dropping a side straight down perpendicular to the x-axis, not across to the y, but down to the x-axis. This creates a little right triangle that does not have the obtuse angle 120 in it anymore. Instead, it has what's called a reference angle. The reference angle is located here at the origin. Sometimes it's labeled with a theta, which is just a 0 with a slash through it. It's a Greek letter. This is called the reference angle, and this whole triangle we just created is the reference triangle. These are two really important things that you're going to hear me throw around today as we find out what some of those sine, cosine, tangents things are for angles that are obtuse, if you will, okay? So now let's take a look at drawing some of these angles and trying to find that reference angle. So we're going to sketch the angle, find the reference triangle, and then find its reference angle. So if I was going to draw 120 degrees, my initial side or my beginning side would be right here. Ooh, sorry. Let's go back. Would be right here drawing along the x-axis. And this would be 90, 180, and I need to go a little bit more for 210. This is 210 degrees. Now, where is the reference triangle? The reference triangle comes from my end side of my angle, the one I just finished drawing, straight up to the x-axis. Boom, up to the x-axis here. This is my reference triangle. My reference angle is in this corner right here, right there, little theta. We need to figure that out. How many degrees would that angle be right there? Well, 210, let's see, I went past 180. How many degrees past 180 did I go for 210? 30 degrees, right? So this guy right here would be a 30-degree well, a 30, 60, 90-degree triangle, in fact, but his reference angle in here would be 30 degrees in this corner by the origin. Let's draw 110 degrees. So over here, initial side, here's 90, a little bit more past 90. This would be 110. So where's my reference triangle? Reference triangle comes from the end side of my angle straight down to the x-axis. Here's my reference triangle. I need to find this degree right here. Well, if this is 110, how many more degrees do I need to get to 180? 70, right? So that has to be a 70-degree angle. So this is what we're talking about when we're talking about reference triangles and reference angles. Now, what if some of these angles happen to be negative, ladies and gentlemen? Yes, you can have negative angles and draw negative angles. It's a direction. So just like the other angles, I'm going to start right here on this side, and I need to go negative 130. Now, positive 130, I stretch around the top part of my graph first. Now here for negative 130, I'm going to go down first. So this would be negative 90, a little bit more, boom. This is negative 130. So if I draw my reference triangle again, drop it to the x-axis here, it's just going to be underneath the x-axis this time. How many degrees would be right here? 50, right? Because 130 plus 50 would complete this half 180 degrees here, or half of a full rotation around. What about negative 295? Woo, here we go. Here's my initial side starting. Here's negative 90. Here's negative 180. Here's negative 270. Oh my. And then, I don't want to go all the way around because that'd be 360, right? But I do have to go a little bit past 270. Okay, so this is negative 295 degrees rotation that I just did. Now this creates a little triangle here that I can drop straight down to the x-axis, making 90 degrees, and I need to figure out this angle right here in that corner. Well, if that's 295 degrees out of 360 to get back all the way around, if I take 360 and subtract 295, that gives me 65 degrees left to get me all the way back around to that 360 mark, okay? So this idea of drawing the big angle, even if they're over 180, and then finding that reference triangle is what allows us to figure out what it means when we talk about taking the sine of a 120-degree angle. Okay, so think with me for a minute. How would I draw 120 degrees? This involves just pictures. Here's my x and y axis. And remember my initial side, I'm going to start right here. And I'm going to do 120 positive. So here's 90 and a little bit more. This is 120 degrees. Now, the reference triangle that I'm actually using is now dropped down to the x-axis, this guy right here. There's the actual triangle for me to use to set up sine and whatnot. But I need to figure out the angle, the reference angle in my triangle. This would be 60 degrees. 120 plus 60 degrees more would make my full 180. So I have right here, ladies and gentlemen, a 30, 60, 90-degree triangle. This angle would be 30. So this is really important. This kind of brings the two sides together here. Why do we need to know both? Well, now I see a 30, 60, 90-degree triangle. I can use my relationships to help me out. In a 30, 60, 90-degree triangle, I have some facts. The hypotenuse equals 2 times the short leg, and the long leg equals the short times the square root of 3. So for both of these formulas, they both depend on the short leg. In our triangle, we don't have any numbers here. We get to make up some values because it doesn't really matter as long as they have the right ratio. It doesn't matter what values we really make up here. But we're going to make one up for the short leg. The short leg is probably easiest to work with if we just call him 1. Because it's easy for me to multiply it by 2 and multiply it by the square root of 3 to find the others. Notice that I put the 1 across from the 30 degrees because the 30 degrees is the smallest angle and the shortest side will be across from it. From there, I can now figure out the other two sides. The hypotenuse is 2 times the short leg. That'd be 2, right? And the long leg is the short leg times the square root of 3, so that would be square root of 3. Now, because this is actually on a coordinate graph, now notice how I have 1 going here on the left-hand side where the x values on a coordinate plane are negative. This really becomes negative 1. If I am going to set up the sine fraction now of my reference angle, which is this guy right here, sine 60 degrees is my reference angle, what's the sine fraction? The sine fraction is square root of 3, which is opposite, over hypotenuse. So square root of 3 over 2. Now that is a good answer. I love this answer. It's simplified, it's exact. There's no rounding involved. What happens when you hit the sign of 120 in your calculator? You get a funny decimal, right? 0.8660. Well, what is that? That's a rounded answer. But what is the square root of 3 over 2? You guys, that's that same value, except I don't round. This is exact. This is the simplified version. This is what many calculators that do radicals will give you, and you're wondering, why? Where'd they come up with that? This is it. Okay, this is where sine, cosine, tangent, and special right triangles come together. So let's take a look at another one. Cosine negative 225. So first of all, I'm going to draw a picture. We have 2 more examples here, 3 examples of this type of stuff. Okay, let's draw our negative 225. Here's my initial side. I'm going down negative 90, negative 180. If I went 90 degrees more, I'd be at 270, so that seems a bit much. So somewhere in between these two axes, that's where my negative 225 is going to be. Okay, so how do I draw my reference triangle here? Straight down to the x-axis here. There he is. Now we need to find this angle right here. So if I went 225 degrees, I went past 180, right? How many degrees past 180 did I go? I went 45 degrees. Nice. So this guy right here is a 45, 45, 90 degree triangle. So I'm going to place my measurements on this guy just like I did the 30, 60, 90. So in a 45, 45, 90 triangle, the hypotenuse equals, geez, leg times the square root of 2. So we're going to make up some nice numbers for the leg on this triangle. The leg on this triangle, let's call that 1. We could call it 2, we could call it 5, it's not going to matter. It's just we'd have to simplify our answer at the end because we choose bigger numbers, then we have to simplify at the end. So I'm going to call this value 1, I'm going to call this value 1 because it's a 45, 45, 90, the legs will be the same. And then the hypotenuse is the leg times the square root of 2, so 1 times the square root of 2 makes the square root of 2. Do I need to put any negative values on this? Yep, on the x-axis I went over negative 1, I went actually up positive 1, so I don't need to change that to a negative or anything. But now when I set up the cosine of 45 degrees, remember I am here, I'm at my reference angle right in this corner. Cosine is adjacent over hypotenuse. So negative 1 is my adjacent side, hypotenuse square root of 2. Now I can't leave it like that because you can't have a square root in the bottom, so I'm going to multiply the square root of 2 times the top and the bottom, and I get negative 1 square root of 2 over square root of 2 times square root of 2 becomes square root of 4, which is just 2. This is the exact value for the cosine using this reference triangle. Now, if you wanted to test it out and make sure you're right, hit cosine of negative 225 in your calculator. You get negative 0.7071. Test out that radical. That should be the same value. That's how you know you did it right. Okay, last one, tangent of negative 135. So here we go. Drawing the picture, initial side starting here, and I'm going to draw my angle. Down 90, that's negative 90. Ooh, geez, I keep doing that. And then up a little bit more here. Not to 180 yet though, right? And I'm going to draw my reference triangle to the x-axis. This is negative 135 degrees. I need to find out this measurement in this corner, right there. Okay, so what is that? Well, I didn't quite make it to 180, so this time I have to ask myself, how many more degrees would I have to go to get to 180? Well, I would have had to go 45 more degrees. So this is a 45, 45, 90. And again, I'm going to make up nice numbers for the leg because I know the hypotenuse depends on the leg. So legs I'm going to call 1. Hypotenuse is leg times the square root of 2, so I'm going to call that square root of 2. Now let's adjust our triangle based on the position. Are there any negatives I need to add? According to the coordinates, this would actually be over -1, and this would actually be down -1 as well. The hypotenuse will never be negative, okay? Now let's do tangent of 45. You are here at your reference triangles angle right here in the corner at the origin. Tangent is opposite over adjacent. So opposite side, -1 over adjacent side, -1. -1 over -1 is 1. So if you hit the tangent of -135, people, what value should we be seeing in our calculator? 1. Okay, I need you to know how to find these exact values. This ties in to those upper level math classes many of you are going to be in years to come. So if you've seen this before, those calculus classes and pre-calculus classes and even enriched algebra 2 become a lot easier if you've seen how trigonometry takes shape on this graph, okay? So I want to thank you, ladies and gentlemen, for taking good notes today. Kincaid out.